All right, here's our video, the 7th video in our series on the living environment regions, and we're talking about lipids, which basically are fats, oils, waxes. Those are lipids. And basically, they store energy, right? So deep into our past, our primeval past, our primordial past, there was food scarcity, obviously. And so it was essential that we were able to store energy, and that's what fats do. So without fats, we probably wouldn't have survived as a species. All right, so let's get into it. Let's get our pen ready here. All right, let's use blue. So as we've been saying in other videos, we've been talking about macronutrients, proteins. We talked about carbohydrates. We talked a little bit about nucleic acid, DNA. In the last video, we were talking about that. And now we're talking about lipids. So let's get, the pen's not working. We will make it work. Maybe it wants green. So we're talking about lipids, obviously. And so again, they are fats, which have a bad connotation in society, but they are essential. They are waxes, and most people don't hear that. And of course, they're oils. So at room temperature, fats are solid. And we know oils are liquid. What about waxes? Well, your earwax. Your earwax is a lipid. So you know what that is, right? So the thing about lipids, and there will be a however coming up on this, they are not, they're insoluble in water. And I said there's a however coming in there because we will talk about, there are some, actually 2%, that we'll talk about in a minute, that are soluble. But they are insoluble in water, so it means they don't mix. They do not mix with water. And I'm sure you know that. With water, H2O, dihydrogen oxide. So let's get a little picture of that. And I'm sure at some point in your science career, in middle school and high school and in college, but even in elementary school, you would have done this experiment. You know that oil is less dense than water. They do not mix. And the reason for that, very quickly, is there is no polarity in fats, right? Water is a polar compound. And let me briefly talk about that. Now let's do it over here. Change it to red. So and we'll write it over here. So lipids, right? So they're non-polar. They form non-polar bonds. And from chemistry, you should know that there are a couple of bonds here we should know. Well, I'll write it over here. We have covalent bonds, then we have ionic bonds. Well, within the covalent bonds, there are polar, like water, and non-polar, like the fats. So let's write our compounds over here. We'll say compounds, right? Just joining two different elements, compounds. So there can be covalent. Some people say covalent bonds. And then there's ionic bonding. So in covalent bonds, there could be polar. Like I said, polar would be water, forms a bond. And non-polar, we'll just say NP for non-polar. And, like vinegar, which is acetic acid, and nail polish, for example, and the other lipids on that. And ionic bonding is like salt, sodium chloride. All right, so let me write. Let's do different. Let's use green for the non-polar. So the non-polar, like I said, like acetic acid, which is a fancy word just for vinegar. You'll hear it as acetic acid probably in college and so forth. Or let's give another one: ethyl alcohol. Not ethyl alcohol, but ethyl acetate. Right, acetate, which is just nail polish. Ethyl acetate, but it's an E there. I have to double check that one. So anionic bonding, we told they do not share. So in polar, there's a partial sharing of electrons. In non-polar, there's an equal sharing, and in ionic bonding, there's no sharing. So if you took sodium, right, and you bond it with chlorine, and you would get sodium chloride, which is salt. They're not sharing. They're actually, chlorine needs an extra electron, and sodium's getting rid of one. All right. And if you need to know more about ionic bonding, there will be other videos on that when we talk more about chemistry. So let me clear this out. We'll clear the screen here. And let me get a picture to show you. All right, here's an easy picture, very clear. So in a nonpolar bond, covalent bond or covalent, however you want to say it, they're just equally sharing it. They're equally sharing electrons. In a polar bond, there is an unequal sharing. So if I can draw, right? Well, let's draw over here. We'll draw oxygen, that's oxygen with the O, and hydrogen, right? So hydrogen and oxygen are sharing an electron, but oxygen is sharing a little more of that one electron that hydrogen has. So because it's sharing it more, as you can see here, put an arrow over here. There's that delta symbol. It's the lowercase delta in Greek. You might have seen the uppercase in math when you see the change of. That's delta. Delta Airlines, right? And that's just a lowercase. So this is just saying that because there's an unequal sharing, because oxygen is taking more of that shared electron, oxygen is getting a negative charge, and then hydrogen is grabbing this positive charge. So there is a charge here. That's why they call it polar for water. And in ionic bonding, like we said with sodium and chloride, for example, there is no sharing. Sodium wanted to get rid of one of its electrons in its shell, in its orbit, and chlorine wanted to grab one. And again, we have other videos on this in chemistry. Very interesting about it, though, is because sodium by itself, pure sodium, is very dangerous to eat, and chlorine gas is very dangerous. But when you put the two together, it's something essential that we need. And we'll talk about it in a living environment because we have to talk about salts. All right, so let's just go over, and I typed them in here so it's easier. And let's get our pen back. What color am I going to choose? I'll choose that one. So obviously we've been talking this whole video about it, how it is an energy reserve. They regulate hormones. So, and basically, we'll just do a little example on that. Get my pen over there. So they help regulate, when they're controlling hormones, they help regulate our internal temperature. There it goes, right? And they also, because of that, they will help contain inflammation, right? And I don't mean they're going to keep inflammation. You don't want inflammation in the body, but they'll help regulate that inflammation that we get in our body, which is not good for us. Inflammation. They transport, that's a nice word. They transmit nerve impulses. They insulate us, right? So they protect our organs. We need that body fat to protect our organs, right? So, and obviously, the more fat you have, like a polar bear, the warmer they are. So that's a little benefit there itself. They transport fat soluble nutrients. So, for example, these vitamins like vitamin A, which is great for our eyes, and vitamin D for our bones and our immune system, vitamin E, vitamin K. These are fat soluble nutrients that stay in our body a long time, but to absorb them, they need fat. So you can't, when you're taking these vitamins, first of all, they will stay in our body longer, depending. Some can stay up to 6 months. They can stay in your body, but to absorb them, you need fats. They're not like water soluble nutrients that stay less in your body and that you don't need fat. So you might get a nutrient or you might get something from your doctor and they say take this with a meal because they're saying it needs that fat soluble for it to be absorbed. Now let's look at the three types of fat categories. And we'll clear that out. Let's get a fresh page. Right, so here's the three types that I typed up. Triglycerides, you might hear, maybe your doctor says you have high triglycerides, but they make 95% of our diet. So let's write 90. We'll use green. 95% of our diet is triglycerides. Phospholipids is 2%, and you can get them from meat and plants also. They are here's that however when I talked about earlier in the video, because phospholipids are actually water or fat soluble. That's interesting about them. And sterols, you hear about, very important. You'll know sterols as cholesterol, and cholesterol has a bad reputation too, right? And this is not a health video, but cholesterols have a bad reputation because only small amount come from food. Your body makes its own cholesterol, and you need cholesterol for vitamin D absorption, and you need it for sex hormones, for example, and other factors. So they're all vital. So these are the three types that could be broken down: triglycerides, phospholipids, and sterols. Now, in the next video, we're going to talk more about nucleic acid and a little bringing a review together on all the macronutrients. All right, great job.